So let us move on to the next kind of questions. So where one body is on top of the other body, and initially I'll do one without any angles involved. Now look at this question and give the answer within seconds just by analysis. This is going by 2 this side, this is going by 3 that side, and where it should go with how much of velocity, which side, up or down, and how much of velocity. So I'll just urge you to do it by analysis. It is a very simple one. So what is your analysis? How do you do in analysis? Everything stable and move one thing. Say everything, this pulley stable, this is the movable pulley, and this thing stable, and this just goes by 2 forward. Then what happens? How the string will go down, how much it will go down. And once that has happened, it has finished its movement of 2, then this stays put. This stays where it is, and you move the movable pulley, which is going to make this 3 go 3 up, so 3 up, so 3 in. So 3 in, so how much of string will go over there? So I hope you got it. From here, if you loosen 2 with everything stable, so this has to go down by 2. If you move this by 3, then you'll have a loose string of 3 and 3, which is 6. So you have to go down further by 6. So 6 plus 2, your answer should be equal to 8 down. So I hope you have done in almost no time. So one of the ways was, if everything is fixed, this goes by 2 forward, then this will give the string 2 down here. So this will go down by 2 if this goes forward by 2 and everything is fixed. And then when we move this pulley by 3 this way, so that this goes up by 3, then we'll have a loose string of 3 and 3. So to tighten that, this has already completed its movement of 2. I can't do anything to this side, so this string remains put where it is, and this stays put where it is. So I have to give 3 plus 3, which is 6 down over there. So I should get my answer as 8 meter per second down. So 2 supply from here, and 3, which is 6 supply from there. Have a look at this question now. It's pretty much the same concept. It is the same concept, in fact, but there is one unique point over here which might be a point of consideration while we are doing the question. So that will come when we are taking tension, when we are doing through the tension method. But let us just get the answer by analysis. If I move this by x amount forward, what will happen? I'll get a loose string of x over here, I'll get a loose string of x over here, loose string of x over here, because all of this would have become loose by x, nothing to this remains straight. So this is a pulley on the mast. So this pulley is also a movable pulley. So this has gone forward. So I'll get a loose string of x over there also. So ultimately x, and x. We have got 4x loose strings. So this has to go down by 4x. So that is quite straightforward. But somebody who wanted to do it by the third method, that is total work done method, then let me write it properly. Tension. All sections I am drawing the 2 tensions pulling the bodies. Now, where we used to ignore a lot of places where things were not moving, so we used to ignore those places for tension. But here, look very carefully, that points where we have to write the work done by tension is this point, it is this point which is being pulled by 2t, and it is this point which is pulled up. Now this point is what I was referring, where you might miss. So this is attached to the block and the block is going forward. So this tension is responsible for pulling the block. So this tension is doing work and making the block go forward. So writing the equations, the orange ones are the tension. So let me write. So this goes in the direction of tension, in the direction of tension, in the direction of tension. How much x, and x? So we have 4 times t into x. Tx, or 2t into x rather over here, but it's the same thing. So this is what you might miss out. So this is important over there. And here it goes down by, say, a y amount. So a y amount, it goes down, tension was upward. So minus ty is equal to 0, y is equal to 4x. So while you are doing with tension, be careful. When doing with increase and decrease of length, that will be quite straightforward. In this case, this would have reduced by minus x, remains same, minus x. So minus x for this, and this would have increased by y. So we would have got y is equal to 4x. Quite unlikely that I would be wrong by all 4 methods. Okay, so So the point over here, but the only different point over here was there was a pulley which was attached to the block. So when the block moves, the pulley moves. So this becomes a movable pulley. Plus, for sake of forces and all, whatever force is acting on the pulley is acting on the block. So if I am pulling my hair is attached to my body. So if I pull my hair, my body gets pulled. So same way, if the pulley is getting pulled, the block is getting pulled. So this force, this T is acting on the block. If somebody has to write an equation of motion in the front direction, then the total force is on this block in the front direction was T, 40. 40 was the total force in the front direction. So the acceleration in the front direction will be given according to F is equal to ma, that is 40 is equal to mass of this block 2 and acceleration of this block in the horizontal direction, which is the only direction in this case.